All right, now it's time to take a look at the next section, which is still 4.1 operations with polynomials, but this time we're looking at part 2. And we're primarily focusing on this second learning target. I'm learning to find, add, subtract, and multiply polynomials. So the first thing I want to discuss is the degree. The degree of a polynomial is the polynomial with the greatest degree, whatever term that may be. Now, terms must be written in standard form. So polynomials must be written in standard form. So let's make a note. Polynomials must be written in standard form. Which means highest degree to lowest degree. So now we're going to take a look at 5 examples. It says, determine whether each expression is a polynomial. Polynomial meaning more than one term. If it is a polynomial, state the degree of the polynomial. And let's go ahead and state the leading coefficient. Which means the first term's coefficient. So let's take a look. How many terms do we have here? We have 2 terms, so 1 term, 2 terms are each considered a monomial, meaning they have no negative exponents and no fractional exponents. And in this case, we have no negatives and no fractional exponents. So we can say, yes, it is a polynomial. Now we have to find its degree. So the degree is all the exponents added up in a single term. So when we look at this term, we have an exponent of 4 and 3. So 4 plus 3 is 7. And in this term, we have a degree of 5. So what is our highest degree? In this case, it'll be degree is 7. And our leading coefficient is the coefficient of our highest degree. And in this case, that is a 1/4. It is already written in standard form because we have our highest degree, 7, to our lowest degree of 5. Let's take a look at this next example. We have 1, 2, 3 terms. So it could be a polynomial, but we have to take a look. Do we have any negative exponents? Nope, I don't see any negative exponents. Do we have any fractional exponents? Yes, we do. This term right here, the square root of x, can actually be rewritten as x to the 1/2. And we are not allowed to have fractional exponents. So I'm going to make a note, fractional exponents are not allowed. As such, this is not a polynomial. So we'll say no, it is not a polynomial. All right, let's take a look at our next example. We have 1, 2, 3 terms. So it could possibly be a polynomial, but what do we know about polynomials? They can't have negative exponents or fractional exponents. So is this a polynomial? No, it is not a polynomial. And that is because no negative exponents allowed. All right, let's take a look at the next one. We have one term, two terms. So at this point, we can possibly say it is a polynomial, but is it? And the answer is no. And if you recall, the reason why it is a no is because polynomials must be the product of two terms, not the quotient of two terms. So we say no, not a polynomial. And that is because terms must be a product, not a quotient. So product means I can be multiplying, but I can't be dividing. And here, what we have is we're dividing, and we are not allowed to. So we'll go, nope, no dividing allowed. Let's go to this next example. We have one term, two terms, three terms. Do we have any negative or fractional exponents? Not that I can see. Are we dividing any terms? Nope. So that means, yes, it is a polynomial, finally. So we'll say, yes, it is a polynomial. What is its degree? Well, here we have a 5, and this y has a 1. We just can't see it. So here we have a degree of 6. Here we have a degree of 4 plus 3 is 7. Then we have a 1 and a 1, which is 2. So that means our degree, the highest, is a 7. Let's go ahead and rewrite this in standard form. So highest degree to lowest degree. So that says 9x to the 4th y cubed plus x to the 5th y minus 2xy, which means our leading coefficient, the coefficient of our first term, is going to be a 9. Excellent. Let's continue on. You can simplify a polynomial just like you can a monomial. What you need to do is just perform the indicated operations and combine like terms. So here we always have to pay attention. What is happening between my parentheses? So when we take a look here, we have 4x squared minus 5x plus 6 minus the whole thing, 2x squared plus 3x minus 1, which means I need to distribute that negative. When I distribute that negative, it's going to change every single sign. So let's go ahead and rewrite our first set. We have 4x squared minus 5x plus 6. But now when I distribute that negative, I'm going to subtract everything, or just change its sign. So minus 2x squared minus 3x, and now plus 1. Now we have to combine our like terms. X squareds with x squareds, x's with x's, and constants with constants. So 4x squared minus 2x squared gets us 2x squared. Negative 5x minus 3x gets us negative 8x. And then 6 plus 1 gets us 7. And that is our final answer. All right, let's go on to this next example. Here we are actually adding this time. So it becomes a little bit easier. When I add, I actually kind of like to do it vertically. So I'm going to rewrite all these terms vertically. So I have 6x squared minus 7x plus 8. And then I'm going to add this second set right underneath. So negative 4x squared, so minus 4x squared, plus 9x. Notice I'm grouping them underneath their like terms, minus 5. So 6 minus 4 gets us 2x squared. Negative 7x plus 9x gets us 2x. Then 8 minus 5 gets us 3. See how nice that was? I like it when it's nice and easy like that. All right, let's go to the next example. Notice we are subtracting, which means we need to distribute that negative to every single term. So I'll rewrite my problem, negative x squared minus 3x plus 4. Now I'm going to change all my signs. My positive x squared becomes a negative x squared. My positive 2x becomes a negative 2x. And my positive 5 becomes a negative 5. And now it's going to combine like terms. X squareds with x squareds. So I have minus x squared, which is a negative 2x squared. Negative 3x minus 2x gets us a negative 5x. And then 4 minus 5 gets us a negative 1. Nice and easy. We've been doing this. We've been doing this a lot this year. So you got this. You got this. All right. So now we're adding. So I have 3x squared minus 6 minus x plus 1. Now you could do this vertically or you could do this horizontally. Not a big deal. We'll do it horizontally first, and then I'll show you what we have to do special if we're doing it vertically. So x squareds with x squareds. Well, there's only one of them. So we have 3x squared. All right. X's with x's. Remember, we have to do standard form. And then constants with constants. So we have 3x squared minus x minus 5. Now, if I were to have done this vertically, my first set would be 3x squared plus 0x minus 6. And that 0x acts as a placeholder. And placeholders are very important, especially as we go on in chapter 4 and we start dividing polynomial expressions. And then we have our negative x plus 1. And if we go ahead and just go vertically down, we would get the same exact answer. One has a placeholder, one does not. Both get us the same exact answer. So it's really up to you. All right, let's continue going down. So that was adding and subtracting, which means now we're going to look at multiplication. And this is where we're going to take what we know about our monomial rules and apply it to what we know about polynomials so far. So we're going to take the 3x and we're going to distribute it to every single term inside my parentheses. And notice, I'm going to show this step every single time. So 3x times 2x squared plus 3x times negative 4x plus 3x times 6. So 3 times 2 gets us 6. I have 1x here, 2x here. Gets us 3 because we add the exponents of like bases. Now we have 3 times negative 4 gets us negative 12. I have an x here and an x here. They are being multiplied, so when we multiply like bases, we add. And then we have 3 times 6, which is 18. And then we have our x. Just taking what we've already discussed and applying it to something new. Do it again. Multiply that 4/3 x squared to every single term inside our parentheses. So 4/3 x squared times 6x squared plus 4/3 x squared times 9x plus 4/3 x squared times negative 12. Now, if you want, this is where your calculator will come in very handy. We could take 4/3 times 6, and that's going to get us 8. I have x squared times x squared. The bases are the same, so we add our exponents. Now we'll go 4/3 times 9 in our calculator, which gets us 12. Once again, we have like bases of x, so we can add our exponents. 2 plus 1 is 3. 4/3 times negative 12 gets us negative 16 x squared. All right, let's keep going. We have to keep distributing. Distribute the negative 2a to every single term. So negative 2a times negative 3a squared, negative 2a times negative 11a, negative 2a times 20. Coefficients first, negative 2 times negative 3 gets us a positive 6. Same base, add exponents, so I have 1 here, 2 here, so 1 plus 2 is 3. So now I have negative 2 times negative 11 is positive 22. Same base as a times a, so 1 here and 1 here, so 1 plus 1 is 2. Negative 2 times 20 is negative 40, and then we have our a. And there we have our answer. All right, so those were monomials times polynomials. And now we're going to do a binomial times a trinomial. So here we were doing 1 term times 3 terms, 1 term times 3 terms, 1 term times 3 terms. But now we have 2 terms times 3 terms. And that just takes an extra step in that distribution. So here, the n squared gets multiplied by n and by the 2. So n squared times n plus n squared times 2. And then we do it with the 4n. 4n times n, 4n times 2. And then the last term, negative 6 times n, negative 6 times 2. All right, same basis, add exponents, so n squared times n, so that's 3, plus n squared times 2, 2n squared. 4n times n, same basis, so we add n plus n, so that's 2, 4n squared. 4 times 2, 8n, minus 6n, minus 12. Now, let's see if we have anything we can combine. We can combine the 2n squared and the 4n squared, as well as the 8n minus 6n, because it's just combining like terms. We've done this already this year. It was a while ago, but we have done it. So this is like a review. So we have n cubed plus 6n squared plus 2n minus 12. All right, next example. We got to distribute again. X squared times x. X squared times negative 4. Notice, I'm writing this down every single time. Mrs. Younger's been doing math longer than y'all been alive, but I'm still writing it down every single step. So I highly would suggest that you write down every single step, Because if you make a mistake, it'll be easier to find out where the mistake was made when you're writing down all of the steps. And then 16 times x, and then 16 times -4. All right, same basis, add exponents, so x cubed. I'm going to do this in black. So x cubed minus 4x squared. Then 4x times x, same basis, so add exponents, so plus 4x squared minus 16x, because 4 times -4, plus 16x minus 64. Let's see if we can combine any like terms. We have x squareds, we have x's, so we have x cubed. Now I have a -4x squared plus 4x squared, so those cancel. And then I have negative 16x plus 16x, so those cancel, and I'm just left with negative 64. Which consequently, I believe, is a difference of 2 cubes. All right, last example of the day. Make sure we're distributing. 2x squared times 3x, 2x squared times -1, negative 4x times 3x, negative 4x times -1, positive 5 times 3x, and positive 5 times -1. We get 6x cubed, because we have 2 here, 1 here, minus 2x squared, minus 12x squared, plus 4x, plus 15x, minus 5. Find our like terms. So we have 6x cubed minus 14x squared plus 19x minus 5. And that's our final answer. We've done this. This is just a review. If you have questions, please feel free to email me. Other than that, don't forget to do your assignment.